So this one is question 5 from electricity experiments, alternative to practical. So in the question, a student is investigating a power supply. He uses a circuit as shown. So you can see a voltmeter is there, which is connected in parallel. An ammeter is there, which is connected in series. A resistance wire is there and the crocodile clips. A student connect a crocodile clip to the length 100 centimeter and the resistance of a wire measured a potential across P and Q. So this length was set at 100 centimeter and then student measure the voltage and the current. So record the values of the voltage and the current. What is the voltage here? You can use screen annotation or you can use chat, you can use mic to state the value. So voltage is 2.1. And how much is the current? So each line, as you can see, there are 10 lines are there. So each line is 0.02. So this is 0.0, like 0.22, 0.24, and this will be 0.26. So that will be equal to 0.26 ampere. Then calculate the resistance of 100 centimeter. How to calculate a resistance? It is V naught divided by I naught. So V naught was how much? The V naught was, the voltage was 2.1 and the current was 0.26. When we divide them, we'll get the resistance, which will be 8.1, and the unit of the resistance is ohm. It's already written there. It's already there. Just we write 8.1. Then student then connected the crocodile clip to length 170 centimeter, 80 centimeters, 50 centimeter, like changing the length between the crocodile clips. Initially, it was 100 centimeter, then changed to 70, then 50, then 40. As you can see, different sets of results are there. So this is a length. We have to calculate the and record the value of 1 over I. How to get 1 over I means you have to take just a reciprocal. So I is 0.35. What will be 1 over I? So it will be 1 divided by 0.35. So 1 divided by 0.35, that is 2 point, yeah, the 2 significant, that's right, 2.86 will be there. Then we have to plot a graph between 1 over I and L on y-axis and y. So we need these values for length and 1 over I, 70, 60, 50, 40, 30, and 1 over I. So 1 over I, that is 2.86, 2.50, 2.27, 1.89, and 1.54. These are the values for 1 over I. So we have to plot a graph for length on y-axis and 1 over I, and we do not need to start from axes from the origin. So what does it mean? Like you don't have to start with 0, you can start with any number. And length should be there. As you can see, length is on y-axis and 1 over I on x-axis. So we have length that is on y-axis and 1 over I, and the unit is 1 over ampere, that is on x-axis. So minimum value of a length is 30 and the maximum value is 70. So we just have to scale this according to 30 and 70. So if I start example with 30, then after 10 boxes, it will be 40. Then after 10 boxes, 50 will be there. Then we will have 60. So whenever you select the axis, you should at least cover 70% or more than that. So this will be 70 and then 80 is also there. When you check the value for the x-axis, because 1 over I is there, so minimum value is 1.54 and the maximum is 2.86. That means I can start with 1.5. So example, if I start with 1.5, then after 10 boxes, if I select like uh, after 5 boxes, 1.6, then further 5 boxes, 1.7, one 1.8, 1.9, then 2 will be there. But if you if you select in this manner, so this will be 2, because the maximum value we are getting at 2.86. So we have to, so this will be 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8. I have 2.86, so I should add 2.9 as well. So this will be 2.9 and then we'll have 3. So these are the numbers, like marking the axis, labeling the axis, that you will score 2 marks, like selecting a suitable scale and labeling the axis. Now, the points what we have, now we mark the points. So first point, 70 and 2.86. So 70, this will be 2 point, because 5 boxes are there, so each is 0.2. This will be 2.82, 2.84, 2.86. So this will, the third line after 2.8 will be 2.86, and then 70. So this will be 70 and 2. Then 60 and 2.5. So 2.5 is this. And 60. Then 50 and 2.27. So 2.26, 2.28. This is 2.28. And between them will be 2 point, and this is 50. Then we have 40 and 1.89. So 1.88 and 1 point, so this will be here. And then 30 and 1.54. So 30 and 1.54, this will be 1.54. So these are the points which we have. Now, whenever you're drawing the line, you should draw a line of a best fit. A line of a best fit means like number of the points above and below should be same. So, some student have a confusion. They ask like how they will know that whether they have to draw a straight line or they have to draw a curve. Usually, a simple way to identify whether you have to draw a straight line or a curve, check the next part of a question. If they ask for a gradient, then it should definitely be a straight line. If they ask to determine the gradient of a graph, it means it should be a straight line. So if you are confused, like whether you have to draw point to point or you want to draw a straight line, just check the next part. If they ask that gradient, so it is confirmed that it should be a straight line. So what you will do, you will draw a straight line, line of a best fit. Line of a best fit, the number of the points above and below. It's not like you always join the first and the last point. The idea is that the number of the points which appear on the line above and below should look same. So as you can see, when I try to draw a line of best fit, one point is above, one point is below. And this second point is also there above, but like relative distance, it cancel out. Like the number of the points above and below should be same, or the relative distance of those points. If I select like this, so it is approximately, this point is above, this point is below. And when you're finding, the next point was finding a gradient, you have to mention on your, you have to show your working of finding gradient. And whenever you're finding a gradient, try to take a maximum spacing between the points. The distance between the points, try to maximize that. So example, if I take this point and the second point is this one. So first point on x-axis, that is x1. So how much is this x1? So 1.62466668. So x1, I will write it here. So x1 is equals to 1.68. What about y1? So this is like 31, 32, 33, 34. So this one is 34. So y1 is 34. Then we took another point on x-axis, that is x2, which is 2.7. And this one is 65. So y2 is equals to 65. Now finding the gradient, what is the formula for gradient? y2 minus y1 over x2 minus x1. So y1 is 65. Sorry, y2 is 65. y1 is 34. x2 is 2.7 and x1 is 1.68. What's the final answer for the gradient of this line? y2 65 minus 34.
30.3.
30.3. Okay. But 30.34. Okay, 30.4. So we determine the value of the gradient. Here we got the value of the gradient the way we solve. So example 30.4. And then they're saying calculate the electromotive force EMF of a power supply by using a formula. So all these values are given. So E is equals to G. G is the gradient here, 30.4. R naught. What is R naught? If you don't find what is R naught, you just go through the question again and check which position they write R naught. So you can see this is written R naught. And what was the value of R naught when we calculated? It was voltage, it was 8.1 when we divide the voltage with the current. So value of the R naught is 8.1. And what about the value of the K? The value of the K is 100. So what's the answer? 30.4 times 8.1 divided by 100. 2.46. So the EMF is equals to 2.46 volts. So for paper 6, you don't have to memorize any formula. It's just you have to check these. This is important, like representation of gradient is G, representation of a resistance is R naught here. So you just have to use the values from your question and find the answer. Then ammeter in the circuit has a small resistance which affects the current. The effect of a resistance, the effect of this resistance of measuring a current will be different for each measuring length. State and explain which length will be most affected by the resistance of ammeter. Like what they are saying, when we are measuring a current here, the ammeter is also having a considerable resistance. Like there is a resistance of ammeter. So, and we are changing a length here. We took like example 30 centimeter, we took 40 centimeter, we took 50 centimeter, 70 centimeter, and we took 100 centimeter. The question is, like if I say ammeter was having a 4 ohm resistance, example. So the question is, which length will have a considerable effect for the resistance of ammeter? So when the length was 30 or length is 100, which length you think will have an effect on the current which is passing through an ammeter? Considerable effect. So the correct answer is 30. Length of a 30 will have a considerable effect as compared to length of 100. But what is the reason for that? Like, look, already, if I say when I was using 100 centimeter, okay, when I was using 100 centimeter, this was resistance of 8.1. And if I say, example, an ammeter was having a resistance of 0.5. So when ammeter was having a resistance of 0.5 example, and the total resistance of a 100 centimeter length is 8.1. So what is the combined resistance of a circuit? It is 8.5. But if I use a length of a 30 centimeter, if I use a shorter length, the resistance of a wire will be smaller. So resistance of this part of a wire will be smaller. So most of the resistance in the circuit is due to ammeter. That is why in that case, the resistance of the ammeter will have more effect on the current as compared to other part. Like when the length is 100 centimeter, the resistance of this part is higher and the ammeter part is lower. So ammeter does not, resistance can vary. Yes, resistance of a wire can vary. Resistance of ammeter is same, but resistance of wire can vary as we change the different length of a wire, use a different length. If I'm using a longer wire, resistance will be higher. If I use a shorter wire, resistance will be less. So when we use a shorter length, like example, when we use 30 centimeter, so that case 30 centimeter resistance is lower and ammeter is having a considerable resistance, it will affect the current in the circuit. Ammeter resistance is not changing. Ammeter resistance is same, but the ratio, like because the total circuit resistance is equals to resistance of ammeter plus resistance due to length of a wire. When we are using a 30 centimeter length, resistance is this resistance is ammeter example, say resistance is 4 example, and resistance of a wire example 1. So what is the total resistance of a circuit? 5. But most of the resistance in the circuit is due to ammeter. But when we are using a length of a wire which is 100 centimeter, so it is also resistance of ammeter plus resistance of a wire. So ammeter resistance is 4, but the resistance of a wire will be higher, maybe like 8. So most of the resistance is now due to the wire. So when we are using a longer wire, most of the resistance is due to the wire. So the current is depending on the resistance of wire. But when we are using a shorter wire, a wire of a shorter length, the resistance of a wire is smaller. So most of the current which is passing depends on what is the resistance of ammeter. So ammeter effect most when the resistance of a wire is shorter. Is it clear this one? How ammeter, what condition ammeter resistance will be more considerable, like it will affect the current? So this is a question. In ammeter is a circuit is having a small resistance. So state and explain which length most affected the resistance of ammeter. So we'll mention a 30 centimeter length will have a greater effect. The reason is that because the length of wire has smaller resistance. at 30 centimeter. So most of resistance is due to an ammeter. Like, and ammeter is contributing to greater part of a resistance.